Hello and welcome to Postgres FM, a weekly show about all things PostgreSQL. I'm Michael, founder of PG Mustard, and this is my co-host Nikolai, founder of Postgres AI. Hey Nikolai, what are we talking about today?
Let's talk about optimization of budget. First of all, for infrastructure costs. I mean, if you run a database and it grows, obviously it increases your bill, cloud bill usually, sometimes not cloud, of course. And there's a question which becomes more and more acute: how to pay less for it, and how continuing to grow in terms of your company growth, how to reduce the costs. And I think it's the topic that can be interesting for both infrastructure and engineering teams, and it's becoming more and more important because we have crisis already. A lot of people are fired, unfortunately, are being fired, and this is one of the questions. Like if you can optimize infrastructure costs, probably it's a good way to optimize it. Maybe you can save some jobs, right?
Yeah, it feels like we've gone through a boom period where a lot of people were throwing money at problems and maybe doing a lot of things and having a lot of costs that they don't necessarily need longer term. So hopefully in some bigger environments, there's some big room for improvement. But also I think for smaller companies, there's often ways of reducing costs there as well. So yeah, I'm looking forward to this one.
Right. So let's start with clouds maybe. There is a good article, it's actually like maybe 2 years old already, from Andreessen Horowitz. It's called The Cost of Cloud, $1 Trillion Paradox. And obviously clouds are super interesting, super like revolutionary concept which changed engineering drastically, right? But observation is that with all those additional services, when companies start, it's great because it helps them to focus on product development and finding product market fit and so on faster. But then, obviously, the bill grows significantly. Of course, the companies like AWS, Google Cloud, Microsoft with Azure and others, they win a lot. And if we consider the market, it's growing. But if you right now do a simple exercise, I did it recently, and take some, some medium size server, for example, Intel or AMD server with 16 cores, 128 gigabytes of memory, for example, and compare the costs of EC2 instances or GCP instances versus the price of the server if you buy it, for example, right? Of course, it's extreme right now. Everyone wants right now to run just API call or run Terraform task and provision instances. So it's so good. Nobody wants to deal with ordering servers, then replacing disks. It's like it's nightmare from the past. But if you compare those costs, or also there are some low-cost providers like OVH or Hetzner, where you can rent servers and they will be replacing failed disks, CPUs, and so on. You will be wondered why it's so high. So my first question when we talk about database infrastructure cost optimization, where do we run it? And extreme optimization is to go with rented servers or with own data centers if you're a big company, and it will compare the costs of maintenance, of course, because if you use clouds, maintenance costs, ownership costs, and so on. But it might be a total sense to, for example, to go with rented servers or with your own data center. For smaller teams, rented servers. For larger teams, your own data center to build it. But of course, there are a lot of many questions here. It's not a database only topic, definitely. But I would like to mention one important key here. with Kubernetes and a lot of automation we have, for example, we can run Postgres with Kubernetes, or we can run it with Ansible easily. We have a bundle of Postgres, many options. For example, PostgreSQL cluster. One of person from my team maintains it, Vitaly. It's a great product, open source, so you can run it from Ansible, and it has backups, Patroni for auto failover, everything. So you can manage Postgres yourself, or Kubernetes. It's like full-fledged automation, and achieve a lot of good results. With low cost here.
Did you see the recent blog post by the team at Basecamp, or at least DHH? I think they're a MySQL setup. But yeah, they were talking about exactly this, and
it's insane how big the bill is right now. If you grow, if you have you pay a lot. Of course, at this scale, you already should negotiate large discounts with cloud provider, obviously, 100% so.
But I think
large, I mean 70%. It's not like 20 or 30, 70, 80% discount. You should do it. If you pay more than 1 million, I think you already do it.
Yeah, probably that's the kind of thing people are already doing. But it does feel like there are people starting to question: are we getting the benefits that the cloud promised? Are we still having to employ people to do a lot of the infrastructure things, having to worry about the lower level things? If you are, then are we really are we really happy paying those premiums? But equally, I think that's a very, very high effort way of potentially saving a lot of money. And it feels like probably in the rest of the list we're probably going to cover some things that are lower effort. Maybe they don't save quite as much money on an individual item basis, but you might be able to do them sooner.
Right. I wanted to emphasize that this should be exercise you do constantly from time to time. I mean, if you're CTO or something, or database the database lead in your company. I don't say go bare metal with Kubernetes, but it should be considered, analyzed when you do capacity planning. And I also must say, clouds and managed services like RDS are awesome. All those clouds, like every cloud is awesome. Ivan, Timescale Cloud, Supabase, Hasura, Neon, all of them are great. All of them provide a lot of value. But you need to deal with pricing. You need to analyze costs and consider alternatives. And we helped several our customers to make decision. And it's always not an easy decision. So on one hand, you to go to RDS or not to go to RDS, to go to Aurora RDS or to go with Kubernetes. There are options there as well. Maybe another topic, right? So it's always a quite hard decision, because you think, okay, I already have a table comparing all aspects of pricing, my budgets, but maybe I forgot something, right? They do provide value. They have good metrics, good characteristics in terms of uptime and durability. Will our infrastructure team can handle it? If it's small, maybe no. If it's large, okay, maybe now it's doing, maybe later it's not. So it's a good question. But still my advice, if you are too small or too big, consider bare metal, definitely. Or rented servers. I mean, if you're too small, consider rented servers. It can save you a lot, a lot. For example, instead of paying 1,000, you can pay 100 easily for infra. But for work, yes, it will require the use of some tools. Yes, it will require maybe some subscription to some services for support. But overall, okay, you'll be paying $200 instead of 100. But before you paid 1,000 to cloud, right? So RDS is great, and without RDS, for example, I think I wouldn't come to idea to create ThinkLearning database lab engine, because first I worked with RDS clones, I understood how convenient it is to provision temporary machines to experiment, to develop better, and then to delete them. And then, extreme case, ThinkLoans was implemented. But, and I'm sure many will remain on cloud providers, and it will continue growing. But in Crisis, it's one of the biggest questions. Should you go self-managed Postgres or managed by some other company, Postgres?
Yeah, and we do have a whole episode on this as well, right? One of the earliest ones, if you've got new listeners making this decision at the moment. that might be worth a listen. But yeah, it feels like a huge decision, lots of work if you're having to migrate. And maybe you don't have to go all or nothing, right? Like there are some services that they're clearly running on very thin margins, like the storage services on the clouds. But the databases do feel like they do have quite a high margin added to them versus the like S3 cloud, like simple storage solutions.
Right. Also, if you go with cloud, there are many optimization techniques there. There are many. It's whole, like maybe we could discuss only this during the whole episode. For example, if you also in cloud means self-managed or versus additional service like RDS, right? Also, everywhere there are trade-offs and decisions to make. So if you run self-managed in cloud, of course you can benefit from various techniques to optimize costs. If you, for example, some people also, like it's extreme technique, but some people use spot instances for even to run databases. In AWS it's better than in GCP, for example. I'm not sure about Azure. I don't have enough experience with Azure. Somehow, like our clients are mostly not on Azure. Also, if you work on self-managed, there are a little bit more options to cut costs, to cut the bill. If you go with reserved instances, for example, you can buy a contract for bigger type instances and also have convertible instances on AWS, so you can then dynamically split large instance into pieces when you need smaller instances. It's quite interesting technique. Also, I learned recently there is a secondary market. You can sell those contracts and so on. There are companies who focus on this cost optimization. For example, if you go, I use service EC2instances.info, which provides, like, I don't know why AWS doesn't provide normal table with all prices on one page, but these guys do a very good job. And the company behind it right now is OneTouch.sh. So they provide a service, automated service to optimize cloud costs for all big three providers. It's quite interesting. I hope we will have a Postgres TV episode with them soon, already discussing. There are many options to optimize there. Also, in terms of computer storage both, I wanted to highlight one thing. There is a serverless approach, which isn't very interesting, but you should very carefully analyze its pros and cons, because like in general it's great. Like, I mean, you pay only for what you need, but you need to understand your workload pattern. If it's spiky, of course it's great, but if it's not spiky, there is some level when going serverless, the overhead you pay for the company for this service itself, it's already too high. So it's like also there are trade-offs. You need to do a lot of work filling cells in some table with calculator maybe and sourcing information from various places.
And maybe some testing, right? Like sometimes paying a little bit to test some things is much better than I saw a blog post not that long ago. I can't remember who it was, so I'm going to find it and put it in the notes, from a company who did a switch to, I think it was Aurora in this case, from regular RDS, and were really shocked at the increase in pricing when they were expecting a decrease. So it's
Aurora, it's making some loop with topics. I wanted to discuss first like clouds, not clouds, and clouds, various types of contracts, spot instances, reserved, convertible, many things to have. For example, I don't know why RDS doesn't have spot instances. Well, okay, I understand. You should, like, it's like stateful, but people do it actually. And if you lose compute, storage is there, and Postgres will recover. For non-production, it's good, but they don't provide it. So, but then you talk about Aurora, not Aurora. On Aurora, one interesting aspect is that on Aurora, the topic of query optimization, which when we prepared for this episode, you raised the query optimization naturally as the first topic, and I said no. Based on what I saw in larger companies, it goes maybe last, but with Aurora, maybe not last, because on Aurora you need to pay for I/O. And if your database doesn't fit the buffer pool, share buffers, and your queries are not optimized. They do a lot of work with disk. In this case, your unoptimized queries hit your bill. So if you optimize them, you reduce your spending, which is good. So cost optimization, query optimization on Aurora directly leads to cost optimization, which is interesting case, but because this is how pricing is organized there.
Yeah, and actually, we probably should go back to some of your bigger ticket items. You talked about some of these bigger companies. You go in, and if you suggest query optimization, they come back and tell you that's a very fine-grained solution. What's the bigger picture is that they've got loads of, I think you mentioned, even unused instances. Of course, if you've got, that's going to be a huge saving if you can just make sure you're catching those early. Do you have any tips and tricks there?
Normally, it's usually a lot of unused instances left after some experimenting. So you need to control those. If your organization is growing, you have, for example, hundreds or thousands of nodes. Of course, if some team provisioned and forgot to shut it down, it's not good. There are services which control cloud resources and help you find those which are not used enough. But I wanted to mention that in non-production, it's better to use thin cloning and branching, so Database Lab Engine. Here, like, I need to advertise my service once again. By the way, we also, since like we are entering crisis, I understood that there is a good need in infrastructure cost optimization. So our consulting wing of Postgres AI team is also working right now on structuring all the aspects of database cost optimization, so our topic today, so we can help with this as well in terms of like to consult as consulting. But in terms of tooling, Database Lab Engine provides you with one machine, you have dozens of clones independent, and this can keep your bill basically constant. While you need to run many clones, you keep your bill constant in terms of non-production databases. And for benchmarking, it's slightly different. If benchmarking, it's heavy benchmarking, you need to run heavy tests like utilizing all cores and so on. Of course, you need to provision full-size clones in cloud. And it's a good question if you can do it temporarily and then shut it down, but big question, you need to not to forget to collect all aspects of all artifacts, logs, monitoring. There are approaches that can be used. For example, I can recommend Nadata because you can export dashboard there, and then you can remove machine. So you need to have centralized log accumulated everything, and you also need your monitoring to be able to remember metrics for instances which already don't exist and keep them longer. And Nadata with export capability, unfortunately it's manual for now because it's front-end feature. It's great. Automation is great, and so on. So this is big. It can be big cost saver if you start with non-production first, like to keep bill sane there. But as for production, several things. First, interesting that my opinion right now is that AMD is better than Intel these days. If you need the beefy server, for smaller servers maybe it doesn't matter that much. But if you need 100, 200 vCPUs, if you need many hundreds of gigabyte of RAM, AMD is better to handle all TP workloads because it provides much more vCPUs for less price. I mean, in terms of, if you compare benchmarks, you will see that EPYC Rome, EPYC Milan is beating many Xeon processors. And of course, big cost saver is ARM. Like Graviton 2 on AWS for smaller servers is good, but it's limited in number of processors. So for really large, heavy loaded databases, it might be not enough to have 64 cores maximum, right? I don't remember from top of my head, but it's limited. It's not like 96, 244 vCPUs others provide already. And AMD, like, if you need a lot of vCPUs, a lot of workload to handle, for example, 100,000 TPS on one node, AMD EPYC is the good way to go. and it's cheaper in terms of power versus money. But if you have smaller requirements, maybe you should consider ARM. And even on RDS, ARM is good, right? So it's already there for a couple of years, maybe.
How much do you see people saving going from one to the other?
It can be dozens of percent. Of course, sometimes it's hard to compare. For example, if you run micro benchmarks, for example, Sysbench is good for micro benchmarks to check CPU, to check RAM, and then FIO for I/O. So Sysbench and FIO is my two tools to use for micro benchmarking. You will make conclusion probably that AMD is good if you need a lot of cores. But if you go to database level benchmarking, the question is how, right? Because if you have this is different question how to benchmark, maybe another episode, right? But in general, your benchmark should be good enough to make conclusions, because if you just run synthetic PGBench, it's not enough. It will be not representative it will be very far from your real workload. So you need to take care of proper benchmarking. And as for ARM, there is also certain type of saving. I don't remember numbers. We did it when they appeared quite long ago for one customer. And they started to use it, but for those instances which need smaller workloads, not like 100,000 TPS.
Yeah, you say smaller workloads. I say normal workloads.
Lower.
For the 90%
normal,
of us.
Okay.
Yeah, 99% probably.
Less than 1,000 TPS. It's normal, right? Okay.
Maybe
it's good.
Normal
maybe
businesses.
You have 1,000 microservices and shrink everything, cut everything to small pieces, and this is maybe if this system is more resilient, right? If you cut to pieces.
Well, that's a good point.
Do you have huge monolith? It can be hard.
You mentioned microservices, and one thing I didn't have in mind, but I wonder if you see, is whether the push to microservices and having lots of databases, maybe a database per application, if there's room for savings, if people combine some of those and,
Well, in general, the rule applies here. If you have some strict boundaries between some resources, of course, if these boundaries are not elastic, they cannot shift to one way or other, you will start paying more. It's like with disk. If you have the need to have several volumes on one disk, and you need to control several free disk space numbers, right? And it already it's some overhead in terms of managing it, and also it will probably be less efficient because somewhere it can be 40%, somewhere it's like 70% free disk space. But if, for example, it can be elastically united to, for example, with ZFS, if you use datasets and you have one single number of free disk space, then just control to be it more than 20, 30, 40% always. And all datasets are using what they need to use, that's it. Right? In this case, same applies to splitting to some microservices. Of course, if you put a database on a separate instance, provide standby nodes for it, some will be underutilized, some will need to grow. Of course, this is how the idea of serverless and auto-scaling appears. This is great that these ideas exist, but they also have some extra overhead, and they won't work in your data center if you go my extreme advice to consider data center, right? So this is an interesting topic. Of course, if your microservices are small, and for future you might consider splitting them to separate instances, but for beginning you might combine them in single Postgres cluster as logical databases, right? In this case, they will share single instance, single resource. For example, RAM and CPU as well. Right now, one of them is using more CPU. It's okay. Then another is using more CPU. It's okay. On average, we have this number. We control only one metric. In terms of SLA and so on, we control only one metric here. It's good. It's elasticity, right? In terms of CPU. in terms of RAM as well, only one shared buffers, one page cache number, and so on. And they adjust, like with spike in one, it's okay. But if you split them as physically in separate instances, you have more metrics to control, and probably cost efficiency drops here, of course.
Yeah, makes sense. Are there any other big ticket items you had that,
Of course, the biggest tip item, like from any DBA or database expert, of course, query optimization is like probably the tip of our hill, right? The top of our hill. This is great topic, and sometimes it saves a lot. My advice is to have, if you have many nodes, first of all, to control pgstat statements in terms of course, regular metrics to control: CPU, RAM, disk, everything, like to see how far from saturation we are. But if you take, for example, pgstat statements, it can provide you interesting metric already. Each second, how many seconds are spent for query processing, right? And if you like, this is quite simple but interesting advice. You compare this metric, seconds per seconds, to, for example, say 2, right? It means that roughly we need 2 cores, very roughly. Of course, there are context switches, other nuances, but we need roughly 2 cores. But in this case, we will be already kind of saturated, right? If we give it 4 cores, we are like 50% utilized. And of course, you don't want to be 50% utilized unless it's some peak hours.
Yeah.
So this is top-level query optimization. Then you dive to details and understand which queries are consuming most of time and try to optimize them. And in this case, if you optimize targeted to resources to help save resources, you need to order by total time. In my opinion. Just statements ordered by total time. And then many details inside. We had an episode about query analysis, macro analysis from top to bottom. And then tools like pgmustard can help to explain some queries and understand how to optimize them.
Yeah, I was actually looking at so total time, I completely agree, but I haven't put it in a blog post yet, but I've written the query now to do it for total buffers as well. So if you're on Aurora, you might prefer to start with looking at total buffers instead of total time. I thought that was an interesting, different angle that you could take. But yeah, so that makes sense. And I think something people don't even consider, and my tool doesn't help with, is do you even need to be doing that query? Like from an application level, how often do you need to be running these things? Do you have things that could be materialized, or do you have things that could be done less frequently? So there's a whole host of optimization at macro level that you could.
If you moving by total time, you find some query which has a lot of high frequency, so calls is very high, but timing is very low. In this case, it's better to apply not query optimization technique, but just application optimization technique, and maybe like to call it less often, to have cache maybe, and so on. This is true.
And I think this is most relevant for folks who are either getting close to thinking they might need, like, let's say you're on a cloud provider, let's say you're on RDS and you're getting close to a boundary where you think you might need to upsize the instance. I've seen people avoiding doing so by doing a whole host of query optimization, but I haven't seen many folks go down an instance size. But it feels like that should be possible, right? Like if you're underutilized, why can't you? I just haven't seen it much in the last few years.
I saw it many times. For example, there is some issue with performance. We come help optimize queries, and then they go down in terms of instance size. This is normal. Actually.
Nice. Yeah, great. That feels like it should be possible. And so if in the past few years you've thrown money at a performance issue?
Even more, they remove a couple of standby nodes because they are not needed anymore because queries are so well optimized. It also happened a couple of times.
Nice. So reducing like read replicas, that kind of thing. Yeah, great.
Because read replicas they mirror everything. And it's like redundant storage. It's good for HA, but in terms of performance, probably it's not good because you cannot access other host memory, right? So you keep the same like it's good to scale read-only queries, but in general, in terms of resource, the use of resources, it's not very optimal actually to scale it like that.
Yeah, super interesting. On the for any smaller, like if people are still listening from really small companies, I think it's also worth mentioning things like a lot of people don't even realize quite how many credits are available for startups. Huge amounts of cloud credits and things that could be thousands or tens of thousands that you haven't used or you haven't even applied for. But yeah, I didn't have much else. Anything else on your list?
I could continue, but I need to drop off for another call. I'm sorry. Let's wrap up here.
Well, thank you everybody for listening. Thank you, Nikolai, and see you next week.
See you. Bye bye. Thank you.
Bye.